Hello everyone. In this video we're going to look at what happens as you trace around a circle, and we're going to reconsider what we're thinking about as inputting and outputting as we trace around that circle. So imagine a Ferris wheel where you get on the Ferris wheel at ground level. This particular Ferris wheel has a diameter of 80 meters, and it's going to take us 12 minutes to complete a rotation around the Ferris wheel. We're going to think of our output as our height above ground and our input as the amount of time we've been on the Ferris wheel. So I just want to pause for a second and draw out the actual Ferris wheel. Okay, so here's a rough sketch of my Ferris wheel. Notice the 40 meters, that would be the halfway point, the halfway height along the Ferris wheel. So as we begin to move along this Ferris wheel, remember we are inputting T as minutes of riding. Okay, so T is our minutes riding the Ferris wheel. And H, this is our height above ground. So it's important to consider those as we look at this Ferris wheel. So it takes us 12 total minutes to get around this Ferris wheel, so I'm considering that in quarters. Every 3 minutes we would cover 1/4 of the Ferris wheel because it's going to take us 12 minutes to get all the way around. So at time t equals 0, that would be the time when I am loading onto the Ferris wheel, getting ready to begin spinning around it. So at t equals 0, our height above ground is 0 meters because we're on ground level. As we begin to trace around this circle, it's going to take us 12 total minutes. So after 3 minutes of time, I would be 1/4 of the way around the circle. So this is 3 minutes of riding here. 3 total minutes of riding. Remember, we are outputting our height above ground. So after 3 minutes of riding, I am 40 meters above ground level. If I continue riding for an additional 3 minutes, so now I've ridden for 6 total minutes. So this is an additional 3 minutes. So now this arc here is representing 6 total minutes of riding. If it's 12 minutes to get all the way around, 6 minutes I'd be at the very top, so my height would be 80 meters. After 9 minutes, so 3 more minutes of riding, I'd be back to this midway point. So now this entire blue arc is representing 9 minutes. And again, my height here, I'd be back at the midway point, would be 40 meters above ground. And if I continued all the way around, I would have been riding now for 12 minutes. 12 total minutes to get all the way around the circle. That would put me back at ground level. So I want to sketch out what's happening here and see what this graph looks like. This is my time in minutes. This is my height above ground. If I use these points here, at 0 minutes, I would be on ground level. After 3 minutes, I'm at a height of 40. At 6 minutes, I'm at the top of the Ferris wheel. At 9 minutes, back to 40 meters. And at 12 minutes, I'm back to the ground. This is one trip around the Ferris wheel. Imagine if I continued this pattern. And let's look at what our height would be after 15 minutes 18 minutes, 21 minutes, and 24 minutes. Well, what would happen at 15 minutes? I would be going from ground level, and during that 3-minute time period, I'd be back to the quarter point, or 40 meters above ground. At 18 minutes, I'd have gone all the way around the circle, plus halfway around. So I'd be back to a height of 80. At 21 minutes, I'd be at the same height as 9 minutes. And at 24 minutes, I'd have done 2 full rotations and I'd be back on the ground. So I would get a graph that looks like this. And you could see that this graph would just continue in 12-minute increments of a full rotation. This is the graph, this is an example of a graph of a circular function. They'll have this type of wave pattern to them. And there's some important features that we need to be able to recognize. The first one is what we call the midline. It's the exact line that would put half of the points above the graph and half of them below it. This would be the midline. We would say the graph or the equation of this line is h equals 40. Our output variable equals 40. The next key feature that I want to identify is what we call the amplitude. The amplitude is the distance from the midline to the top of the graph or from the midline to the bottom of the graph. For this particular graph, this distance here would be the amplitude. Or this distance here is also the amplitude. So to find the amplitude, there's 2 essential ways to do this. The first is to take the greatest output and subtract the midline. So 80 minus 40 is 40. Or you could take the midline and subtract the least possible output. 40 minus 0 is still 40. That's just a coincidence in this case because we're on ground level that our amplitude is equal to the midline. Most of the time that's not going to be the case. In a second we'll look at an example of that. Lastly, the period. The period is the amount of time or the distance along the horizontal axis it takes for one full rotation of a circular function. Since for this particular Ferris wheel, it takes 12 minutes to complete one full rotation, that would be our period. Our period would be 12 minutes. Now I want to talk briefly about the units. The units of the midline and the amplitude would be the units of the output. The units of the period would be the units of the input. So let's just look at a simple example. We want to find the midline, amplitude, and period. So let's assume that the input is x here and the output is y. The midline would be the line that puts half of the graph above it and half of it below it. So this is the midline here. Notice that that is at a height of 7. So the midline here is y equals 7. The amplitude is the distance from that midline to the top of the graph or from that midline to the bottom of the graph. So here, the amplitude we could either say is 11 minus 7 or 7 minus 3. Either way, the amplitude is 4. The period is the length of time it takes for one full rotation. So what we can do is pick a point and determine how long it will take to return to that point along the horizontal axis. If I consider this graph, this is my period here. That horizontal unit distance is 3 units. So the period here is 3 units. In this last example, we're going to look at the graph of a trip around a Ferris wheel and determine these specific features of it. So here we're given a graph of a Ferris wheel. Notice that we're not starting at ground level. This one's asking, what is your height at t equals 0? So here is t equals 0. And in this case, our height is actually 70 meters above ground. The diameter of the Ferris wheel, well, if you notice, here we're on ground level. And the height, the peak height is 140 meters. That tells me that from the ground to the top of the Ferris wheel is 140 meters. So the diameter is 140 meters. Next, we want to determine how long it takes to complete one full rotation. Notice here I'm at a height of 70 meters. We want to determine how long it takes to go all the way around the Ferris wheel. So I'm at a height of 70 meters. During this time period, we go to the top of the Ferris wheel. That's 1/4 of the rotation. We come down from the top of the Ferris wheel back to the midline. Continuing on, during this next stretch, we return to the bottom of the Ferris wheel. And now we return all the way back to our original position. This is one period here. So we need to divide this into fourths. If 12 is 3/4 of the way around, then this must have been 4 minutes, 8 minutes, and then lastly, this would be 16 minutes. So it's going to take us 16 total minutes to complete one full rotation. So how high above ground are you when you load the Ferris wheel? Well, just because we began tracking at a height of 70, that doesn't mean we were 70 meters in the air when we loaded the Ferris wheel. I would assume when we loaded the Ferris wheel, we're actually at this point. We're just tracking the height over time. So when we loaded this Ferris wheel, we're 0 meters above ground. And then lastly, how long does it show you riding the graph? Notice we've done, in my yellow tracing, one full period, which we said was 16 minutes. If you continue that again, you would complete a second period. So we've ridden for 2 total periods. If one period is 16 minutes, and we've done 2, 16 times 2, we've ridden for 32 minutes in the graphed area.